Back online. Okay, so we just figured out that the square root of 1 is one of the answers, and -1 is another answer. So that would be right here. Here's -1. It's technically -1 plus 0i. Okay, so does that kind of make sense with what we think of square roots? It means that if we square it, so x to the 1/2 is equal to 1 or -1, you would think that x, which is this squared, would equal 1, and they both do. Did I say that? I was just listening to me talking. I bet I confused you even more. When you remember, so here's the deal about complex plane that's wonderfully different that I really want to talk to you guys about. And this is over teaching the subject, but there might be one potential scientist or engineer who will get something out of this. When we say the square root of 4 is 2 in real numbers, this is called the principal square root. It's always positive or 0, right? Here's, how do you get the plus or minus 2? Because -2 times -2 is also 4. Here's what they do. This is called the principle of square roots. And it says, by definition, the square root of x squared is the absolute value of x. This is the definition of the square root of a function squared. So if you have this, if you say x squared is equal to 4, then the square root of x squared is equal to the square root of 4. This is the absolute value of x, and this is equal to 2. The absolute value of x is equal to 2. The solutions to this are x equals 2 or x equals -2. This is where you get the two solutions out of here. We're going to see that this really doesn't, a similar thing happens in the complex plane, but for completely different reasons. And actually, if you're considering that real numbers are a subset of complex numbers, this is an interesting juxtaposition on, are these in fact different operations? As I said before, the whole idea that real numbers are an actual subset of complex numbers is something that almost everybody universally agrees upon simply because there's an isomorphic map. But there are some technical details that aren't usually talked about. As a matter of fact, I'm the only one that I know who does. So we just found, okay, so what did we do? We found the square root of 1. And you'll notice, as I said, these lie on this unit circle. Not only that, they're symmetric. And this is what you're going to find for all of these. Let's find the third root of 1. So this time n is equal to 3, and k is equal to 0, and 1, and 2. And then this will be the last one of these I'll do, because as much as I find this fascinating, there's actually a lot more cooler stuff we're going to talk about. Once again, if I'm your instructor, you're going to have a really good idea of what the tests are like, because I always give good fake exams. But if this is being used by another instructor and you don't really know that much about them because it's distance or whatever, for whatever reason, people are just crazy about this roots of unity. I don't know why. It's modestly interesting. Anyway, we're finding the third root of 1. We're plugging the formulas in. Once again, okay, so when k is 0, n is 3, this is really going to be cosine 0 plus I sine 0. This is going to be the first one again. This is the first one. This is for k equals 0. No sense me writing that down again, right? Now, let's let k equal 1. Then we're going to have cosine 2 pi over 3, because n is 3 here, plus I sine 2 pi over 3. Well, okay, so 2 pi over 3, we already know this is 120 degrees, right? And I'll try and draw this as best I can. Okay. And let's see, so what's the cosine of this? I'm going to do my little, so your calculator will tell you this, but here's what I would love it if you knew this. So here's pi over 3, and on this side, symmetrically, which is this angle all the way over here, this is 2 pi over 3. And we can use our picture of pi over 3 on the unit circle to figure out what this is. Hopefully you'll remember that on the unit circle, where the length here is 1, this coordinate point here is going to be, and let me get this out of here, This is the square, this is 1/2. The x term is 1/2, and the y term is the square root of 3 over 2. And I bet I wrote this too small. The trick is that the cosine of 60 degrees, or pi over 3, is 1/2. The sine of pi over 3 is the square root of 3 over 2. It would be lovely if you knew that. You're probably saying, Mike, you dimwit, why are you telling us that? It's over here. But we can use this picture. So this was 1/2. This is the square root of 3 over 2. On this side, this will be negative 1/2. This will still be the positive square root of 3 over 2. Why did I do that? Well, I want to figure out what this is. So this is going to be negative 1/2 plus I times the square root of 3 over 2. And incidentally, we know that the length of this is still going to be 1, right? The norm of this is 1, so let me see. Okay, so this picture may not be perfect. Okay, so this is this. And this point here is negative 1/2 plus I square root of 3 over 2. So there's our second one. Here's the first. Here's the second at k equals 1. Now let's do k equals 2. So when k equals 2, we're going to have cosine of 4 pi over 3 plus I sine 4 pi over 3. And this one doesn't come up that often, so I got to think about it a little bit. But I also know, and this one's not here anymore because we're doing a different one. That was for the 2. We also know there should be some symmetry, right? So this is 4 pi over 3. This is pi and a third. So we start here and we go a third pi. A third pi is 60 degrees. So I guess I'll put this about like here. So this is this coming all the way around. And this is 240 degrees, better known as 4 pi over 3. And you'll notice, so this isn't drawn exactly right. This bit right here, going back this way is minus pi over 3. Coming forward this way is pi over 3. What I'm saying is that this angle here and this angle here are relatively the same. These pictures, if they were drawn right, let me see if I can do a little better job, have symmetry that we can use just like we used here, right? Okay. And so what we have this time, this is going to be negative square root of 3 over 2. The y component here is negative. The x component is still negative 1/2. So this is translates to negative 1/2 minus I square root of 3 over 2. Okay, and once again, we will see that this is that all these solutions lie on a unit circle, or the unit egg as it is drawn. So what were all the solutions? The solutions were negative 1/2 plus I times the square root of 3 over 2, and negative 1/2 minus I square root of 3 over 2. Okay, we only have a minute left here. I'm not so sure how much more time I want to spend on this. You should convince yourself that no matter what, the first solution is always going to be 1. And then wherever the next solution is, it's going to split the unit circle up like that. So it's pretty easy to see. And, okay, I guess I'm just going to let that go. And we're going to go on to some really cool complex exponentiation in a minute.